Acceleration is the time rate of changing velocity, or how quickly an object's velocity changes. In this presentation, I will show you how to solve simple problems for objects moving with constant velocity. Since we live in a gravitational field that pulls on everything near the Earth's surface with a constant force, a lot of things around us move with constant acceleration. A soccer ball that's been dropped or a bicycle coasting down a hill both move with constant acceleration. Constant acceleration means that the velocity of an object changes by the same amount each second. For instance, if the velocity of an object always increases by 5 meters per second, then it has a constant acceleration. One more thing, in physics, anytime velocity changes, we call it acceleration. When the ball rolls up the hill, it has a negative acceleration, and when it rolls down the hill, it has a positive acceleration. Both motions are called acceleration. Starting from rest, an object accelerates at a rate of 12 meters per second squared. What is the velocity of the object at the end of 3 seconds? The first thing we do is to underline the important information. Then we turn the information into variables. VI means initial velocity, and VF means final velocity. Next, we substitute the information into the equation with units. We cross-multiply and solve. Let's check to see if this answer makes sense. Since the object accelerates at a rate of 12 meters per second squared, that means it gains 12 meters per second each second. If you gain 12 meters per second each second for 3 seconds, it makes sense that you end up with a velocity of 36 meters per second. Let's try another problem. An object at 100 meters per second accelerates at a rate of 120 meters per second squared. What will the velocity of the object be after 0.1 seconds? Once again, the first step is to underline the important information to make it stand out. Step 2 is to write the equation, and step 3 is to substitute our information into the equation with units. When we cross-multiply, we see that 12 is VF minus 100. When we add 100 to both sides, we find the final velocity is 112 meters per second. Remember, it started out at 100 meters per second. It accelerated at 120 meters per second squared for 0.1 seconds. That added 12 meters per second, and you end up with 112 meters per second. Since acceleration is the rate at which velocity changes, there are 3 ways to have a non-zero acceleration. We can speed up, we can slow down, or we can change direction. Since velocity is defined as the speed in a particular direction, when we change direction, we also change velocity. What all these ways to accelerate have in common is that in every instance, a net force is needed. Think about it. In order to speed up, slow down, or change direction, you need a net force. This is one of the great discoveries of Isaac Newton. Certain measurements in physics require not only a magnitude, but a direction. If a quantity requires a direction to fully describe it, we call it a vector. The last 3 motion words we discussed have been examples of vectors. You cannot fully describe an object's displacement, acceleration, or velocity unless you specify its direction. If a quantity does not require a direction to fully describe it, it's called a scalar. Time, speed, and distance are examples of scalars. Temperatures is a scalar simply because it's a measurement that does not include direction. This is the end of my presentation on acceleration problems, vectors, and scalars.